Good morning, grade 5. Welcome back to grade 5 mathematics class. How are you all doing today? I hope all the concepts we learned in chapter 3 are clear to you. So let's discuss the questions from revision station today. All of you, please turn to page number 53 in your textbook. Do you see the revision station exercise? Let's discuss the first question. It says, write all the prime numbers between 10 and 40. So what are prime numbers? Those numbers which have got only two factors. Which are those two factors? The number itself and the number 1. So here you are asked to write all the prime numbers between 10 and 40. So which are those numbers? Is 10 prime? No. 10 is a composite number. Why? Because it has more than two factors. 1, 2, 5 and 10. So 10 is not prime. It is composite. So is 11 prime? Yes, 11 is a prime number. It has got only two factors, that is 1 and the number itself, that is 11. So 11 is prime. What about 12? 12 is not prime, it is a composite number. What about 13? 13 is prime. So which are the numbers which are prime numbers between 10 and 40? Those are 11, 13, 17, 19, 23, 29, 31 and 37. So these are the prime numbers between 10 and 40. So is it clear? Let's discuss question number 2. It says, which of the following are co-prime? Now what do you mean by co-prime numbers? See, if the only common factor for two numbers is 1, we say the given numbers are co-prime numbers. So for two numbers to be co-prime numbers, the only common factor for these numbers should be 1. So the first question here is 5 and 12. Which are the factors of 5? 1 and 5. Which are the factors of 12? 1, 2, 2, 3. So do you see any common factors between 5 and 12? Yes. The factor 1 is the only common factor for 5 and 12. So are they co-prime? Yes. 5 and 12 are co-prime numbers. Now what about the next one, B? 16 and 18. So we have written the factors for 16 and 18. Do you see the common factors? 1 and 2. So there are factors other than 1, which means they are not co-prime numbers. 16 and 18 are not co-prime. Now question C, 3 and 25. For 3, the factors are 1 and 3, and for 25, the factors are 1, 5 and 5. So the only common factor for the number 3 and 25 is 1. So 3 and 25 are co-prime numbers. Now what about question D, 11 and 48? Here we have the factors for 11 and here we have the factors for 48. Do you see the common factors? The only common factor is the factor 1. So 11 and 48 are co-prime numbers. Now the next one, question E. There you have the factors of 8 as 1 into 2 into 2 into 2. And the factors of 21 are 1, 3 and 7. So the only common factor is the number 1. Hence 8 and 21 are co-prime numbers. Now for question F, you have the factors here. Look at the factors. You can see there are factors other than 1 and hence the pair is not co-prime. For question H, the numbers are 33 and 45. We have the factors here. See, there are factors other than 1 common to the numbers. Hence, 33 and 45 are also not co-prime. So, I hope this question is clear to you. Now, let's discuss question number 3. Write 16, 36, 42 and 28 as the sum of two prime numbers. So, the numbers you are given here are all composite numbers. You are asked to write each of these numbers as the sum of two prime numbers. So let's take the first number, 16. Let's try to split 16. Can we write 16 as 0 plus 16 to represent it as a sum of two prime numbers? No. Is 0 prime? No. Is 16 prime? No. So we cannot consider this. Now let's consider the next case. 16 is equal to 1 plus 15. Now are these two prime numbers? 1 is neither prime nor composite and 15 is a composite number. So we cannot consider this case also. Now let's consider another case. 16 is equal to 2 plus 14. Are these two prime numbers? 2 is prime whereas 14 is composite. So here 16 is not represented as the sum of two composite numbers. So we cannot consider this case also. Now let's take another case. 16 is equal to 3 plus 13. Now is 3 prime? Yes. Is 13 prime? Yes. So here 16 is represented as the sum of two prime numbers. So let's take this case. Similarly, you have to write up the rest of the numbers given here as the sum of two prime numbers. I have given a few suggestions here. You can check if other combinations are also possible. Other combinations of prime numbers. So I hope this is clear to you. Let's discuss the next question. It says find the prime factors of 45, 121 and 72. So what do you mean by factors of a number? The numbers which can divide the given number completely or exactly without any remainder. And you can write any number as a product of its factors. For example, if you are considering the number 6, it has got the factors 1, 2, 3 and 6. So you can represent the number 6 as the product of its factors. You can write 6 as the product of 1 and 6, and you can also write 6 as the product of 2 and 3. So you can write any number as the product of its factors. So in prime factorization, we are finding the prime factors of a given number and writing the given number as the product of its prime factors, right? So here you are asked to find the prime factors of 45, 121 and 72. So what do you have to check? You have to check which all numbers have to be multiplied to get the number 45. That's the case of 45. And you have to check which are the numbers that can be multiplied to get 121. And same is the case with the number 72. So as the number gets bigger, it might be a bit difficult to find out which are the numbers that should be multiplied to get the given number. So what you can do here is, you can make use of the short division method for each number. So let's take the first number 45, which is the smallest prime number that can divide 45. Is it 2? No. Is it 3? Yes. 3 can be used to divide 45 and we get 50. So 3 is the smallest prime factor which can divide 45. Now we got 15 here. Now which prime number can be used as a factor to divide 50? Again 3. We get 5. Now which is the prime factor that can divide 5 completely? It is 5. So 5 divided by 5 gives you 1. So you keep on dividing the given number with the smallest possible prime factors till you get 1. Is that clear? You keep on dividing the given numbers with the smallest possible prime factors till you get 1. And what you have here are the prime factors for the given number. So which are the prime factors for 45? 3, 3, 5. So how do you write the prime factorization for 45? 45 is equal to 3 into 3 into 5. You can do the same method for 121. I'll show you how you can divide 121 with the smallest possible prime factor. 121 can be divided by the prime number 11 to get 11. So 11 can again be divided to get 1 as the quotient. So which are the prime factors of 121? How do you write its prime factorization? 121 is equal to 11 into 11. You can do the same method for the number 72. So I hope it is clear to you now. Now we will discuss question number 5. It says check whether 25,782 is divisible by 3 or not. So how do you check if a number is divisible by 3? You have to take the sum of the digits, and if that sum is a multiple of 3, then the number will be divisible by 3. So let's take the sum of the digits. It is equal to 2 plus 5 plus 7 plus 8 plus 2, which gives you 24. And 24 is a multiple of 3. So the number is divisible by 3, the given number. So is it clear? Now the sixth question, find the HCF of the following using prime factorization and short division method. And you have got 4 questions here. The first question is 42 and 182. So you are supposed to find the HCF using both the methods, the prime factorization method and the short division method. So here we have done the prime factorization method. We have prime factorized 42 as well as 182. And we know in prime factorization method, the HCF of the given numbers will be the product of the common prime factors. So here we have the prime factorization of 42 and here you have the prime factorization of 182, which are the common prime factors 2 and 7. We need to take 1 2 from here and 1 7 from here and take their product. So the HCF will be 2 into 7, that is equal to 14. The HCF of 42 and 182 is equal to 14. Now we also have to do the short division method. So for doing the short division method, first you have to write the given numbers in a grid. Find the smallest possible common prime factor to divide the given numbers. So here it is 2. 42 divided by 2 is equal to 21. 182 divided by 2 is equal to 91. So we got the first set of quotients. Now we need to find the smallest possible common prime factor which can divide these two quotients. That is 7 here. So 21 divided by 7 equals 3 and 91 divided by 7 equals 30. And the HCF would be the product of these common prime factors, that is 2 into 7. Gives you the same product 14. So it doesn't matter which method you are using to find the HCF, whether it is prime factorization method or short division method, the answer, the HCF will be the same. Now you have to find the HCF of 35 and 175. Then question C is also explained here. You have the prime factorization of 70 given here, prime factorization of 120 and 180 are also given here. You have to find out the common prime factors for these 3 numbers and then take the product of the common prime factors to find the HCF. Do the short division method also to find the HCF of these 3 given numbers. Do the same procedure for question D as well. Now if that is clear, let's move on to question number 7. It says to draw the factor tree of 42, 70, 28 and 110. What is a factor tree? A factor tree is a tree-like diagram that can be used to show all the factors of a given number. So now let's see how can we draw the factor tree for the prime factorization of 42. See, 42 can be written as 2 into 21. But this is not its prime factorization. Let's draw the factor tree and see the prime factorization. So the first step is to write the given composite number at the top, put that in a circle. Now let's write these 2 factors below that. That is 2 here within a circle and 21 here within a circle. Now draw arrows to represent that 42 is the product of 2 and 21. Here 2 is a prime number. It has got 2 factors, that is 1 and 2. So 2 can be written as the product of 1 and 2, but we are not going to represent 1 in a factor tree because 1 is a common factor for all the numbers. So while drawing the factor tree of any number, we do not consider 1 as part of the factor tree. So there is no need to show this 2 as the product of 1 and 2. So for 2, let's stop here. But this 21 is a composite number. We can split that as the product of prime numbers. So 21 can be written as the product of 3 and 7. So we have written that here. Now both 3 and 7 are prime numbers. So right now we have prime factorized 42 and represented the prime factorization of 42 as a factor tree. So which are the prime factors of 42? 2, 3 and 7. So if you are going to write the prime factorization of 42, it would be 42 is equal to 2 into 3 into 7. So I hope this is clear to you now. You have to draw the factor tree for 70, 28 and 110 as well. So now let's discuss the next question. It says, check if 35,724 is divisible by 3 and 4. If yes, can we say it is also divisible by 6? So how do you check if it is divisible by 3? The sum of the digits should be a multiple of 3. When you add the digits of the given number, you get 21, which is a multiple of 3, making it divisible by 3. How do you check if a given number is divisible by 4? You have to check the number formed by the last 2 digits of the given number. Here it is 24. If 24 is divisible by 4, the original number will also be divisible by 4. So is 24 divisible by 4? Yes, 6 4s are 24. Hence, the given number will also be divisible by 4. Now, how do you check if it is divisible by 6? For the number to be divisible by 6, it has to be divisible by both 2 and 3. We already saw that it is divisible by 3. How do you check if it is divisible by 2? All even numbers will be divisible by 2. And we already saw that it is divisible by 4. Then it should also be divisible by 2. Why? Because 2 is a factor of 4. So the given number is an even number. So it will be divisible by 2. And we also know that it is divisible by 4. And hence it should be divisible by 2 as well. So this given number here, it is divisible by 3, 4 and 6 as well. Hope this is clear to you now. Now let's see the 9th question. It says, check if 5,72,972 is divisible by 18 or not. So how do you check if a given number is divisible by 18? See, we have learned if a number is divisible by another number. So if a first number is divisible by a second number, then the first number will also be divisible by the factors of the second number. That is, if this given number is divisible by 18, then this number will also be divisible by the factors of 18. So here, let's consider the two factors of 18, that is the factor 2 and the factor 9. Now let's see if the given number is divisible by 2 as well as 9. If the number is divisible by both 2 and 9, then it is possible that it is divisible by 18. So is it divisible by 2? It is an even number, hence it will be divisible by 2. But what about the divisibility by 9? For the number to be divisible, sum of the digits of this number should be a multiple of 9. So if you add the digits of the number, we get the sum as 32. Is that a multiple of 9? No. So it is not divisible by 9. So when you consider the factors of 18 as 2 and 9, you see that it is only divisible by 2. So can we say it will be divisible by 18? No. So let's write the answer as 5,72,972 is not divisible by 18. So if that is clear, let's discuss the next question. It says find the LCM of the following. So here you are given 4 set of questions. The first pair is 55 and 135. So how do you find the LCM of the given numbers using prime factorization? The LCM of the given numbers will be the product of the common and non-common prime factors. So here in this case, we have prime factorized 55 as 5 into 11. We have prime factorized 135 as 5 into 3 into 3 into 3. So first we will group the common prime factors. So here 5 is common to both the numbers. Now any more common prime factors? No. So the non-common prime factors are 11, this 3 and this 3. Now the LCM would be the product of the non-common and the common prime factors. Hence we have to multiply 1 5 from here, then 11 3 and 3. So the LCM for 55 and 135 is equal to 1485. So similarly you have to work out question B. Here we have question C. We have the numbers 84, 112 and 49 prime factorized here. We have to identify the common and the non-common prime factors and take their product, and we get the LCM as 2352. Please work out question D also in your notebook. Now let's move on to question number 11. It says find the maximum size of each of the two bottles if oil contained in 2 cans of sizes 84 liters and 144 liters have to be filled in them exactly without leaving any oil behind. So, read the question carefully, and it says find the maximum size of each of the 2 bottles which can contain the quantity of oil. One quantity is 84 liters and one quantity is 144 liters. So, there are 2 cans. One has the capacity 84 liters, one has the capacity 144 liters, and you have oil in both these cans. Imagine that you need to divide the 84 liters and 144 liters exactly. Both have to be divided exactly. So, here what you are asked to find out, you are asked to find out a common factor that can be used to divide both 84 and 144. And it says the maximum size. So, we need to find out the highest common factor which can divide both these numbers, that is 84 and 144. So, you can use the prime factorization method or the short division method to find the HCF. So, here I have shown the short division method. So, 84 and 144 was prime factorized using short division method, and the HCF was found to be 12 or 12 liters. So, this is the maximum size of each of the 2 bottles. So, I hope this is clear to you. Now, let us move on to the next question. It is question number 12. Find the LCM of 225, 324 and 450. So, to find out the LCM of these numbers, first you have to prime factorize these numbers. So, how do you write the prime factors for these numbers? You can use the short division method for each of the numbers given here. So, you can use short division method to find the prime factors of 225 and do the same for finding the factors of 324 as well as 450. Now, once you get the prime factors, you can express the given number as the product of its prime factors. Now, the next step is to identify the common and non-common prime factors and take their product. So, when you do that, you will see the LCM of these numbers here is equal to 8100. Try that yourself and see if you are getting the same answer. Now, the next question, question number 13, is to find if the given numbers are divisible by 2, 3, 4, 5, 6, 9 and 10. So, here you have got a table and a few numbers. You can apply the divisibility rules to check if the given number is divisible by the other number. For example, 2342. Is it divisible by 2? Yes, it is an even number. The ending digit is 2. So, you can write yes here. Now, check if it is divisible by 3 and write yes or no here and so on. So, I hope the questions we discussed today are clear to you. Make sure you complete all the questions, and there is a worksheet given in page number 54. Please go to the worksheet also and complete writing the answers to the questions. So, that's all for today, children. We'll meet in the next class with a new chapter. Till then, bye.